Ravin sir, can I start the program, sir?
For your schedule, please start.
Okay, sir. Sorry for the delay. Good afternoon to one and all. Myself, Dr. T. Srinivas, Professor of Civil Engineering and Dean PG Studies, and also convener of this Faculty Development Program. It's my honor to introduce respected Dr. Jandyala N. Murthy sir, Director of GRAT, respected Sri Gopala Krishna Rao sir, Chief Guest and today's speaker, respected Dr. Praveen sir, Principal of GRAT, respected Dr. GVV Satyanarayan sir, HOD of Civil Engineering, GRAT, and my dear all the participants of various engineering colleges across the state, a warm welcome to this online one-week faculty development program on advancements in construction materials and practices during 30th July to 3rd August 2024. An objective of this FDP is to help the faculty to update and enhance the knowledge on advancements in construction materials and practices as part of lifelong learning process. As we know, faculty are the role models of the students, so it is our responsibility as a teacher to update the knowledge and skills and share the same to students. This FDP has eminent speakers with vast experience in industry. So it is a good opportunity to all of us to learn many things, what is happening in the field apart from the academics. This FDP covers the topics on design of pile foundations, including micro piles, IoT-enabled system for water purification and generation, road safety awareness, developments in the fields of building construction and relocation, and next generation concrete. Total 80 faculty have registered for this FDP from various engineering colleges in Telangana state, and few faculty from outside state also, few faculty from Maharashtra and Chhattisgarh also. All the very best to all of you and happy learning. Now I welcome Dr. GVV Satyanarayan sir, HOD of Civil Engineering GRAT, to say a few words on this occasion.
Thank you, Dr. T. Srin. Good afternoon, one and all. I respected to our director, Dr. J.N. Murthy, sir, and our principal, Dr. J. Praveen, and participants. Welcome to 1 week faculty development program on advancements in construction materials and practices. In my few words about my college, Gokaraju Rangaraju Institute of Engineering and Technology started in the year of 1997. BTech Civil Engineering program started in the year of 2008. Later on, MTech Structural Engineering program started in the year of 2014. The Civil Engineering department is fully furnished with the latest NDT equipments like tropometer PM600, that is rebar locator, tropometer corrosion, and UPV as well as rebound hammer. And our college established loading frame with 2000 kilonewtons in transverse direction and 200 kilonewtons in lateral direction. This equipment was established in the year of 2019. So all participants are requested use this opportunity to enhancement of your knowledge in your consent age. Thank you, one and all.
Thank you, Satyanarayan sir, for sharing your views. Now it's my pleasure to welcome Dr. J. Praveen sir, Principal of GRAT, to share his views on this occasion.
Thank you, sir. First of all, I want to congratulate the civil engineering conducting this workshop on advancement in construction material and practice. So I'm very happy you're spending your time in learning new technology. So if you see civil engineering, so a lot of advancements are coming, and also in India also you can see many new projects. For example, SETU is there, and they have constructed the tunnel, which is world's the tunnel constructed at the altitude, and so longest, and also our government a very big bridge on China river. new things are coming actually. As a teacher, it is free to uh, educate our students on these new technologies. And also see, now we are having concrete, and also building means previously we used to have walls and we used to call it building, but now having smart buildings is having IoT and like security. Then we have safety, security, and many other things are actually, designing building. We need to actually give proper importance to these new construction material coming actually. So previously we used uh, um, different materials, but lot of materials like new plastic and so many materials are used in construction actually. And also 3D printing. So all IIT Madras and other IITs and few other demonstrated both nationally and internationally how to 3D printing, uh, printing actually. So entire building we can 3D print, and by that can save the timing of construction, and also we may reduce of material, and many things are coming. And also softwares are there which are used design structures and design buildings, projects, etc. So we need to learn and also share our knowledge to students actually with respect to these things. And also I advise civil engineering to take our students to new construction sites actually. Many, for example, about 50 stories are coming.
Madam,
Earlier,
Zoom open.
earlier we used to think that all things are coming in only Dubai. Now in Hyderabad also you can see 50-story building coming up. And I have seen one bro where 250 and they are having a on roof. They are small connecting bridge between these two buildings. So projects actually see that take our students, and students should see how actually technology they are using and all. Similarly, so I'm very happy that civil government is doing very good consultancy work. So consultancy work you're doing. Try to also for other areas of work like designing and other consultancy work also. So once again, I want to congratulate, and I hope you learn new things from the industry. And from my side, all the best to all faculty members to learn technologies. And also want to thank the industry members sharing their knowledge and helping this teaching learning community to build with respect to technologies. Thank you.
Thank you, Praveen sir, for sharing your views. It's my honor to welcome today's speaker, Sri S.V. Gopala Krishna Rao, to start the session. Before start the session, I request Mrs. K. Hemalata Madam, Assistant Professor, Civil Engineering, to introduce the speaker.
Good afternoon, everyone. It's my immense pleasure to introduce the speaker of the session, S.V. Gopal Krishna Rao Garu. He is a civil professional with an experience of overall 34 years in structural design and execution across power, transmission and distribution, substations and renewable sector. He recently retired as Associate Vice President at Tractable India Private Limited, a global engineering consultancy company. During his working tenure, he has worked on national and international courts, STADPRO, SAP 2000, L-Pile and PLS Tower, and is also well versed with Microsoft Excel. He has worked with and successfully managed various Indian government and private and also international clients with his expertise and proficiency in the profession. Earlier, he worked in AP Transco for overall 22 years. Then he took VRS at the level of superintendent engineer. His educational qualifications are his Bachelor of Engineering from Manipal Institute of Technology and Master of Technology in Industrial Structures from NIT Surat in 1985. Thank you, sir. Thank you for accepting our invitation. Now I request Sri S.V. Gopal Krishna Rao Garu to please proceed with the session.
Thank you, madam, and thank you, Sir Dr. Srinivas. So, good afternoon to eminent teaching faculty persons. So, I will be sharing few of my experiences. So, thank you, thank you. So, can I take the control, madam?
Yes, sir. Yes, you are the co-host now. You can
Yeah,
share
yeah.
your screen now.
Okay. Sir, please share your PPTs and go ahead, sir.
Okay.
So at the bottom, you have share screen on green color. You have to click on that.
Yes, I'm. Yeah, entire screen I'm
Yes,
clicking.
the entire
Yes,
screen.
okay.
You can go to the presentation.
But it is not coming, madam. Hello?
Sir, open
Yeah.
PPT now, sir. Yeah, PPT. Yes. This mail is yes.
Is it
Yes.
visible?
Yes, sir. Please keep it in the slideshow mode and
Okay, okay.
start. Yes. Yes, sir. Now it is clear.
Yeah, actually, I was have got an opportunity to design some river crossing pile foundations for EHV transmission lines, and also worked in micro piles extensively for the renewable solar PV projects. So whatever I'm sharing is all that's all actual problems delivered at the site and implemented. So I have divided this topic into four parts. One is the introduction to the piles and pile types and the general design process, and some river crossing tower foundation. I will give brief how it will be designed and what are all the main critical process. I'm not highlighting the step by step, but I'm highlighting the what are the critical steps and other things, and few case studies also I wanted to share. Yeah, as you know, the piles are basically classified based on the material and the type of construction. So the timber piles, erstwhile, it is very common in our olden days, and even today, if you go to South Asian countries like Philippines and Indonesia, you can see a lot of resorts were constructed on the timber piles, and even in our India, if you see the eastern part where the flood intensities are more, generally they constructed a two type wooden story buildings. First floor they stay, and second ground floor they leave it as it is, or it may be used for the living of the for the for keeping the cattle and other things. So then, after timber, concrete is now very popular, and everything is going on. And steel piles, see many micro piles, and all oil and gas offshore structures. Mainly, either it is a steel pile or a composite pile with filled with concrete and other things. And even nowadays, FRP piles also coming, and that's gaining popularity because of the corrosion issues and other things. So depending upon the construction also, we can classify the piles. It is a driven piles or a driven board cast into piles, or precast driven piles. Like that, the method of construction also we can say that these piles not only for the river crossing and many hydraulic structures also, it is used as curtain walls or the cut-off walls. Basically, it serves the purpose of the anchoring the crosshead structure or to the river bed, as well as increase the creep length and to maintain adequate levels of uh, gradient water gradient pressure. So these things are very common. So now see, these are all the things how this piling is nowadays. We got earlier many piles, even large piles were done with what is that winch technique, and it was taking a lot of time and all. Now because of the latest machinery, introduction of the latest machinery and technology, and the hydraulic piling machines, and are very common, and even for micropiles also, a lot of people are using the ordinary tractor or whatever the JCB or hydro with modifications. They are using these kind of the pile driving for the micropiles. Very common in India also, because if you go to Rajasthan or Gujarat, where the renewable penetration is very, very intensive, and even ordinary the farmers also, they have modified their tractors, they are doing for the micropiles. So these piles nowadays, it could be a cast in situ piles, or it could be a what is that precast piles. And nowadays, because of the quality issues and these things in many South Asian countries, the spun piles are very popular. Like whatever the LT spun piles is sun LT pun pools, precast pre-stressed pun pools, like that. These are readily available in the market, and I have used one of my projects in Indonesia, and we'll discuss so many things. And second figure, you can see this is called a ramming mission. If you see the blue color mission and other thing, it pushes the concrete profile, sorry, steel profile into the directly into the hard soil or whatever the type of soil, and there is no concrete is involved. It is a form of micropile. It is being very popularly used for renewable energy and road works in other countries. So these piles could be vertical piles, or it could be batter. It can be used as a batter piles, especially in the oil and gas sector and harbors, and where the lateral load intensities are more. This batter piles or the lateral piles are very extensively used, and because of this latest technology in the machinery and GPS advantage, we can fix the batter and we can drive the pile in a hydraulic fashion also. And earlier, if you see that if you want to pour a 1000 pile of around 40 meters or so, earlier it used to take 3-4 days continuous boring and other things. Now the same thing can be done in a few hours. It will be depending upon the stiffness of the strata or the stiffness or strength of the strata. It could be 5 hours, 4 hours, or even less also. So this kind of advantages have come. And this micropiles, I wanted to say, nowadays this micropiles is getting very much popularity, because see, the instead of you can use hybrid foundations, conventional footing with micropiles, that will minimize the footprint of the foundations, as well as it will also will be very helpful in negotiating the heavy loads in a restricted zones also. So for this example, I wanted to share the people who are traveling on the ORR. You might be seeing that the monopole foundations, the monopole foundation, earlier it was having a raft of around 10 meters by 10 meter or something like that. And it is very difficult to accommodate it between the service road and the ORR. So the gap is available is around 7 meters. Then so after coming, some of my colleagues who are working in the transmission sector, they contacted me, and we have gone for this micropiles, and we have reduced the size to around 7 meter by 7 meter and 7 meter by 5 meter in few cases. So these are all the things. So micropile is nothing but it acts like a anchoring rod or the foundation bolt. So it will anchor the superstructure to the subsurface strata by means of small piles. Any pile less than 300 is called as the micropiles. It could be a steel, it could be a concrete, or it could be a steel with grouting and other things. So many things are there, and it is being very widely used in other countries, advanced countries. Yeah. So this is the typical conventional this one hard rock foundation for the any foundation. Simply you dig a hole, or you remove some part of the rock, and you introduce some kind of reinforcement rods and anchor it to the your foundation or superstructure to the paper form of this anchor rods. Not only that, the major load transmission is between the friction between the rock and the concrete surface, and the partly the uplift loads is transmitted to the anchor rods, and there you have to see uh, the one is the force equilibrium between the rod and the grout and the soil surface, and grout and the concrete barrier, and the rock barrier. The intensity of friction is to be considered to distribute the loads, and it is being safely working, because I have seen many foundations in the rocks in transmission lines. They are doing extremely well. I don't want to discuss all these design procedures and all. It will be available in all the textbooks and the literature. So I wanted to briefly explain the gist what we are doing and what is going in the actual practice. Yeah. Yeah, see, any pile foundation, it is a pile foundation. How the load distribution is mainly between the bearing action and the friction between the soil strata and the the pile concrete, whatever the pile surface, the perimeter, there you will, if the perimeter frictional load is a very component, then we can say it is a frictional pile. If the load bearing through the bearing action is predominant, it is called a load bearing pile. And many of the piles it is a partly load bearing and partly frictional piles. So that way, the C5 values of a given soil is very much important, and one has to be very carefully select these critical design parameters from the geotechnical investigation. And many of the geotechnical investigations, they recommend they give their recommendations mostly from from the actual laboratory test, UC test or UV test, whatever may be the thing, that triaxial or unconsolidated compressive shear strength test. Mostly many of the projects, they will not go for the soil sampling. They do the correlation using some standards for the using either SPT or the static cone parametric test. And these correlations, one should be very careful whether we are doing the correlations diligently or not, because I have seen many of the geotechnical report, so many people, with due excuses to the geotechnical fraternity, see, they copy and paste many of the reports, and same thing it will be coming and all. And whoever wanted to select the design of a foundation, the C5 values has to be relooked, and appropriate values has to be considered, because I've seen some failures based on simply they have gone whatever they recommended by the geotechnical fraternity. So it is better to check from our end also whenever we wanted to do all the things at the actual parameters. Yeah. So now when it comes to the piles, it can be a single pile, it can be a group of piles. So when we wanted to use a group of piles, so there will be a subsoil pressure bulb of each pile, and these piles, if you put these piles very close, what will happen? The overlapping of the pressure bulbs, and it will also not a good sign for the design, and it may lead to some problems later because of the increase in the pressure intensities and all. That is why there is a restriction for the pile spacing. The pile spacing is governed by some ethical rules, some empirical rules. So something like that, 3D is a very common thing, and you can go out even up to 2.5D also, some with kind of sometimes reduction in factors while assessing the pile carrying capacity and the other things. And mainly the load transfer is between the soil structure interaction. So it can be done in a very simple fashion, or it can be done in FEM mode. You can develop so many FEM models, and you can do all the things. And it all depends upon the tool, the analysis or the design tool, whatever the tool you are using, and everything. And if you see a behavior of a long pile, see the behavior. The deflection curve of the long pile is it is shown in the right side curve, and some of the basic concepts of how the lateral springs are connected for a very long pile, and accordingly you can see the deflection after particular depth, the lateral deflection of the pile is almost a very very insignificant value. You can see that the curve. I think, hope you can see my cursor. Yeah, these things. Okay, these are all the pressure the grouping and overlapping of the pressures and everything. Yeah, these are all the few what is that orientations or the configurations of the pile groupings, very popularly used, two pile or three pile, four pile, five pile, six pile. This grouping of the pile, it all depends upon the magnitude of the load, type of the subsoil strata, and the space available for the foundations, these things, and the construction facility, whether the whatever the type of foundation is there, whether you used to go for a large number of small piles or go for a bigger number of a small number of small larger diameter piles. It all depends upon the economics of this project, and the economics, ease of execution, and economics of the overall cost implications also one has to look into that. So the pile foundation need not be a concentric. Automatically, see, none of the pile foundations are completely concentric. Many things are eccentric foundation. Depending upon the eccentricity, you have to go for the different configuration or different orientation of the your pile caps. So these are all some figures we have shown it, and how these things are there. Okay. Yeah. So when we see, you can go for a software for complete pile design. Either it is a single pile or it is a group action of the complete pile. And when we design, we will see the individual pile design as well as the group action of the pile, and whichever is least only we will take for the complete design process. And the pile reactions, the distribution of the pile reactions, you can see it is like a simple what is that bolt forces, actual bolt forces distribution depending upon the eccentricity. Same way it can be done, and these things are calculated. And as we aware, the extreme piles will attract more intensity of loads. Yeah. So this IS 2911, it has got 4 parts. In the first part itself, it has got part 1, it has got 4 sections. It is a driven cast institute piles, the board cast institute piles, driven precast institute piles, and precast piles. So all these things are basically, there are minor changes in the equations, or that some factors, k factors and other things. Basically, by if you see the gist of the calculations, the process and everything, principle is they are insane. So in India, the adoption of timber piles are very very less, and part 3 is exclusively for under-rimmed piles. It is based on the Central Building Research Institute for actual testing data. And whenever you want to design the under-rimmed piles, please go through there are several notes, 1 to 10 notes are there. So please carefully look into that notes and then operate the table accordingly, and as per the number of bulbs, then it will give better results. At later date, I will show you some of the 2 buildings I have done in a very very treacherous zones. So I think they have performed very well, and I will share some pics also. It is after 25 or 30 years period. I'm just seeing that pics. I collected this pic so exclusively for this presentation. Okay, so whatever the design we do, it should be validated by the actual testing. So the field testing is the final thing which will validate the design. So as you know, aware that any structural member, it is very critical for the lateral loads. Say the wind, seismic, many of the dynamic loads or the lateral loads are very critical than the vertical load. The same way the piles are also critical for the lateral loads. The lateral load carrying capacity will decide the number of piles and its orientation and everything. So that we will see in coming slides. Hope am I audible to all? Hello?
Yes,
Hello?
sir. Yes, sir. Yes,
Yes.
sir. It's
Yeah,
very
yeah.
clear.
Yes, sir. Yes,
Yeah.
sir.
Go ahead.
Yeah, so when we wanted to design any pile foundation, we have to find out whether this pile is a long pile or short pile. So for that, there is some empirical factors, T and R values. T is exclusively for the non-cozy soils, and the R is for the exclusively for the cozy soils. This calculation and the assumptions, everything is clearly defined in our code, and depending upon that. You have to find out what is the T value, what is the R value, and then finding out, we will do the rough design, and accordingly we'll know the what is the length of the pile. So based on the length of pile, it will be correlated, it will be compared with the T. See, if length of the pile is less than 2T or 2R, it is treated as a short pile. So if the length of the pile is greater than 4T or 3.5 R, it is treated as a long pile. This process of calculation of this everything is given in the annexures of 2911 section 1. So this is the thing. For first we have to find out, and for these calculations also, everything depends upon the SPT values and the cohesion values and phi values. Yeah. So this load bearing capacity, how it is calculated, it is given in the appendix of the code. And the if you see this one, I hope I think my cursor is clear to all. The first one is belongs to the bearing resistant, and the second second part of the formula is belongs to the frictional resistance. When we do the frictional resistance also, there are some restraints are there. The selection of the K, it is mainly depends upon the phi value or the K value. And the PDI, that is the intermediate, that is the overburden pressure at the intermediate center of CZ of that particular layer. It also, it has got restriction. It should not exceed the 12 times 16 times diameter of the length of the pile. After that, if it is going long pile also, you have to restrict to the 16 times the diameter of the pile. So these are all the equations it is given, and the basic procedure and everything. So generally, the pile design process, we are adopting the factor of safety of 2.5, and uh, you can allow 25% extra for the extreme load cases, that is seismic or the wind, and this is allowable. 25% is not acceptable for the if the lateral load is predominant. Suppose a structure you have designed is a wind predominant structure, and the wind load is governing the load case, then this increase in allowable stress is not at all allowed. And we can allow 10% overloading on the piles, 10% overloading with the reduced factor of safety, or a reduced calculation of factor of safety and other things. And the generally the thumb rule is 3 times the diameter of the pile spacing is 3 times the diameter of the piles. And in case of loose soils and other things, you can also increase the diameter, the spacing of the piles. So then whenever we use the pile foundations, invariably we will go for the either trimmy type concreting. It is under either underwatering or underwater condition, or it is ordinary condition. If it is if we don't met with any subsoil, then underwater will not be there. But even then we have to use the trimmy technique. So trimmy technique means the concrete, there is no compaction is possible, because if you want to compact it, the whatever the driven hole or the driven uncased part of the pile bore will collapse. So then what is the trimmy technique? Trimmy technique is a volume displacement. It is a self compacting concrete, and it will the concrete placed at the first, it will come always at the top. That is way. So because it is a it is a self-compacted concrete, and also it contains the first part of the first instant, whatever the concrete we are pouring, it will also mix with some kind of soil particles and other impurities. So that is why you have to flush out whatever the after, when it reaches the ground level, you have to flush out at least 1.5 to 2 times the diameter of the pile. That much volume of concrete you have to flush out it. Otherwise, it will be very weak concrete. It is not. It will may not give a sound concreting pile concrete surface. So that is the thing, and many people they ignore these things, and we have seen spalling of concrete of even river crossing piles also at the above the ground level, whatever the pile surfaces perimeters, we have seen a lot of spalling of concrete also. And because of this trimmy type concreting, and we will be using 10% additional cement content, and the minimum cement content fixed is 400 kg. Nowadays, M20, M30 and M40 grade, you can get it at 320 kg or 350 kg or even less than 300 with the proper batching and other things and everything. But if you wanted to go for the pile concreting, it is better to use 400 kg minimum cement content. And the design of pile foundation, it consists of two parts. One is geotechnical part, geotechnical design, and second one is the structural design. Geotechnical design will dictate what is the length of the pile, number of piles and other things, and the rest, the second one will come the structural part of the pile. What for the given loading carrying capacity of the pile is the whatever the pile we are designing geotechnically, that should be safe and sound when it gets that magnitude of loading. Yeah. So we were talking that the pile design means it shall be invariably validated by the actual testing. These are all the actual test photographs. If you are doing a big project, they use the concrete blocks. And if you are in a very good industrial installation or some kind of place where you will get a lot of steel plates or the steel material, then you can use the steel plates or everything for the plate testing, pile load test and other things. This is instead of that, we can see this batch. It is around, I think this pile was around 900 tons or 1000 tons. It is tested. So much of lab or so much of effort is required to form the cartilage for keeping above the reaction of that compression pile and everything. So to avoid all these things, you can also divide. You can especially frames also, so that it can be used for the both uplift and compression tests also. This frame we have used for 1800 metric tons for 1500 dia piles in Godavari river crossing. Okay, these are all the testing photographs. Yeah, these are all the actual test load setup for the lateral load test. It's a elaborate one because it's a big pile. That's why the lateral load magnitude is very high. Yeah, this is the setup for the load lateral. And when we plan for the testing of piles, even the sequence of testing and the test piles laying also, it has got some important point, because what we will do, always we will do the compression test first, then lateral, then uplift. What they will do, they will use these two piles as a reaction piles for testing the uplift file. So here, so this is the one pile used for the lateral load pile, and this is the one pile used for the compression test. So this is the one it is tested for the uplift. So this pattern and the location, and also it will be chosen such that it can be done like that. Otherwise, you have to do a lot of elaborate arrangements. Whatever we have seen here, this kind of arrangements these are all very expensive. So, friends, the load testing of a big pile is a very expensive thing. It is expensive, and it may cost a cost of one foundation. So that is why, in earlier in my career in the 90s and all, we used to test for each river crossing location. That means the 3 piles or 4 pile locations. We used to test 3 piles. That was giving a huge amount. Then after seeing our experience, we have see that means you should have a very good control over your design and how it is done and all. We have nowadays we are not taking testing that much seriously, or otherwise we may test the one of the pile as per the working load up to 10% or even up to 100% the loadings, and we can see whether it is there. And even nowadays the latest equipments, hydraulic equipments whatever coming, some of the equipments you can really assess the what is the skin friction and what is the bearing strength of the pile. Also some hydraulic jocks, they got special provisions, and you can see the load carrying capacity. You can ensure the load carrying capacity of each and every pile. So that I will also show you something. Okay. Yeah, this load test is, as you know, that I think many of your people might be already associated with the load test and everything. Yeah, this is the load test curve. This is the actually first load testing, and when we are doing the reloading, we will also observe the rebound and everything, and the actual settlement will be the net settlement will be the total settlement minus the rebound settlement, whatever that is there, rebound settlement. And the safe load will be 2/3 final load correspond to 12 settlement, and 50% of 10% of the diameter of the pile. Settlement correspond to 10% of the diameter of pile, not exceeding 25 And sometimes we are taking 2/3 load corresponding to 6 for the small micro piles and all, and we are adopting lesser factor of safety also. For renewable energy, few projects they adopted 1.5 and 2 because their loads are very small, and the testing and all done very fast in a very simplified manner. Yeah, see, these are all the pics, some of the pics of the some major river crossing near Rajahmundry. So there, this island formation and all is a very Hercules task, and it requires a lot of use resources. Nowadays, forming a bund, it will be a very costly affair. Yeah, these are all the one of the Krishna river crossing, and here precast beams were used, and sorry, one location it is cast into beams, and other locations we have used the precast beams. These foundations were validated by the vetted by the IIT Chennai, and this river crossing pile foundation was vetted by the Professor Dayaratnam sir. Yeah, this is the conventional foundations we have done with tie beams and all. This is Krishna River crossing near Jurala. Yeah, these are all the things, and this is a very hard, soft disintegrated rock, and we have raised the chimney so that the flood will go below the tower, and because this is a very hard strata, because the chances of covering is very less. That's why we have taken it, and we have to complete this line on top priority to avail some of the government of India some concessions. That's why we did it everything, and we closed it within 3 months or 4 months. And already this is around 20 years old line, and we have not seen any damage or any risks for these lines. Yeah, these are all the tools. These are all the cutting, bailing edge and cutting edge, and these are all the things, and cleaning bucket. These are the rock chiseling things and other things. Yeah. Yeah, this is a bentonite circulation plant. This is the one of the thing important for the pile boring. Any if the soil is loose, and if you don't want to go for casing up to full depth, there are see, in case of driven piles, what is there? We will drive the casing up to the bottom, and we will concrete it, and we will remove the casing one by one. For a small diameter pile, 600 up to 600, 750, it is okay. But for a big diameter piles, even removing the casing is a hectic task. So that's why. So what the bore is stabilized with the bentonite slurry, and there are strict regulations for maintaining the maintenance of the bentonite slurry circulation. Its density, because the surface tension of the bentonite slurry will give lateral support to the loose borehole subsurface perimeters. So these are all the things. And the major challenging task in the piling is lowering of the reinforcement cases and its joining to the one piece of the case to the other case, because this will take a lot of time. Actually, if the nowadays, if the latest equipment, if you prepare a bore of around 6 hours, less than 6 hours, this lowering will take at least 8 to 10 hours, because it requires a lot of efforts. You require 2 3 cranes and 4 5 welders, and we have to do all these cases. Everything will be fabricated in advance, and you have to just lift it and weld it piece by piece and lowering. And if you see the number of rods, the number of rods are used. It's more than 26 to, it will be around 90 or 100 numbers of rods will be there. So that is why we have tried even mechanical anchors also. That is also not giving that much good results. So what we do, we will weld it. So we will maintain the same development length, because we don't want to take any risk on that, and we will tack weld it and we will lower it and everything. Yeah, see, this is the trimming technique and other things. Okay, these are all the volume displacement is a method of the board pile. And after this comes, it has to be at least 2 to 1.5 to 2 diameters of the concrete to be spilled out, so that whatever the impurities at the bottom of the borehole, it will come out. Yeah, these are all the actual pics of the some of the completed foundations, and you can see the liner. Generally, this liner we will take up to the cover depth level, or wherever the loose soil strata is there, it is required, it is there. And up to 1 meter 6 mm liner we can manage, but over 1000 mm diameter, it is better to go for 8 mm thick liners. Otherwise, the liner will bend. Uh, okay, you can see the things. It all depends upon the quality of the concrete. Whatever the concrete you are doing, it should be durable, very sound. And you can see that there are no other honeycombness or anything. That quality control is very much important. Yeah, this is the one of the critical pile foundations. I was involved, I was associated with this project. Actually, I only finalized this pile foundations. This is a Narmada river crossing, just around 60 kilometers from the Arabian Sea, that near Baruch, some around 10 kilometers or 15 kilometers away from the Baruch. This crossing is there. And this soil is very, I can say, one of the worst soil in India, because the SPT values are lingering around 20, because we kept this pile approximately at around 20-25 SPT values. And already around 18 years completed, it has already witnessed the 100 years flood after its completion. And it's a huge tower, and we have adapted 5 numbers of 1500 dia piles, and it was executed by SR projects. And the length of the pile is around 65 meters. And to maintain the tie beams, we have developed steel tie beams. See, this is without steel tie beam, and the tower was erected, and afterwards the tie beams were erected. And in between tie beams, we have provided the walkway also to attend the maintenance works and everything. And this is a huge tower, approximately 120 meters height, and it is span is around 780 meters span. Yeah, this is the general brief introduction of pile foundations and the design concepts and everything. Now I wanted to see some of the case histories of some pile foundations. Yeah, this is the one recently we have done for one project near Polavaram Barrage for AP Transco. On behalf of somebody else, I did it because they want me to involve in this one. That's why my juniors or the many they are in a higher positions. They want me to involve this position, so that's why we did it. This is also a 1,000-kilometer span tower, and it is approximately just very close, around 500 or 700 meters away from the that new Polavaram spillway connecting to the main river Godavari. So here, actually, 32 numbers of piles, 12 dia piles are there. And here also we adapted approximately 65 or 64 meters length of the piles. And the cover depth is around 43 meters. So we can place this number of piles configuration in a different fashion also. Why we are taking it is, this is the flow direction. You can see, I think everybody seeing this arrow. This is the flow direction, river flow direction. This is the transmission line is going like that. So here the water current force is a predominant force. The tower is experiencing around 200 or 220 tons of lateral load, including all the conductor tensions, wind loads, and everything. Whereas the river water current force, the lateral load due to the water current force acting on the piles up to cover depth level from a MFL is around 990 tons. You imagine what is the balance. So that's why we provided 4 number of piles in this direction and 2 number of piles in this direction. And we have given some kind of some bell shape to take care of advantage of the K factor. See, if it is a circular member, K is equal to 0.6, 0.7. If it is a rectangular member, K is equal to 1.5. So we wanted to minimize the water current force on the pile caps. That's why we put it like this one. So we'll go to a little details. So this is the river Godavari. From here to here, approximately 1 kilometer, and this is 1 kilometer. So overall, this crossing this central tower where we put the pile foundation. This is the conventional foundation. This is the conventional foundation. This is the river crossing pile foundation. So you might be seen last week, few weeks back, that 17 bridges have collapsed in Bihar. I think everybody aware of it. Many bridge failures of the 17 bridges are mainly because of the cover depths. The Bihar is a special region. So here, many of the Ganges tributaries are many of the major Ganges tributaries, Gandak, Koshi. These two rivers are the very, very major tributaries of Ganges, and it will enhance the Ganges flow like anything. So they converge, they meet in the Ganges within 70 to 80 kilometer region, and there in rainy season, the entire eastern region is receives a lot of rain, and whatever the runoff coming from the Nepal is a very steep slope, and whatever, see, approximately if you take Gandak, it is just entering from the hilly terrain into plain terrain in India board. Same way the Koshi also. All these rivers are coming with a huge amount of kinetic energy because of the hilly terrain. They enter with a very whatever the river velocities, whatever the sediment, even trees and the sedimentation and whatever it is coming, the debris loads are very, very terrible. That is the reason why the scouring effect in Bihar is much, much severe than any other part of the India. And if you see few of the rivers in Danapur or Darbangi regions, you can see that the river bed level is approximately 10 to 20 meters lower than the existing ground level, bank level. And many of the banks are eroding like anything. And the government of Bihar is putting a lot of efforts to safeguard these banks, and they are doing a lot of social security for the upliftment of the local people and other things. Because I have traveled those areas extensively when I was in Southwest. So I had an opportunity to see all the things. So that is the reason why many of the bridges, see, whatever the IRC formula given, it has to be given some weightage for the Bihar rivers, especially where the flow velocities are considerable. So here also what we did, we have gauged, we have two times we have gauged the complete river cross section, and we have calculated what is the area of flow, and we have calculated we have taken the maximum discharge of 36 lakh cubic lakhs of flood discharge, and with that we have calculated the average velocity of the river. So at the average velocity of the river is coming around 5.24 meters per second. And same way, we have taken the total width of the river and we divided the discharge. You got the average discharge based on the effective water flow. That also we have calculated. That is also coming around 5.6 or something. And whereas one more, if you see the IRC formula, if you see carefully, there is a footnote that small q is there. The IRC formula is, I don't know whether I can, yeah. See, it is a unit discharge value and the silt factor is there, and q by f rise it to 1/3 into some k value is there. So k value is 1.73 or something. That depends upon the size of the things, other things also. So that also, that concentrated flow discharge is the selection of that one is the most important. What we did is, what is the deepest position? What is the average velocity? So we know the existing deepest bed level, and we taken the average velocity. We calculated unit discharge in that area. So that is giving a considerably huge value. See, regular discharge is coming something around 71 and 72, and this one is coming around 86. We have taken 86 and we have calculated the cover depth is 43 meters. This is two times the actual theoretical cover depth. We adopted 43 meters, and cover depth is always measured from the MFO level. So if this is the MFL level 28.4, this is the actual bare figure 43 meters, whereas these levels are the reduced levels. So 28.4 is the MFL level, 11.83 is the bed level, and minus 14.6 is equal to cover level, and the cover depth is from the bed level is 26.43 meters. So cover depth always measures from the maximum flood level. So with this, you have to do this kind of exercise, and you have to judicially arrive the cover depth parameter. Otherwise, we will land in a big issues. I will show you some photographs, the inadequacy of the cover, how it has gone and everything. Yeah. So based on that, we calculated all the things, whether it is a long pile, short pile. This is all are the long pile. This is the 3D visualization in the STAD model, everything and all. Yeah. Here I think we can show something. Yeah, you see that the actual loading from the superstructure on the pile foundation is coming the 2277 kilonewtons. That is around 227 tons. Whereas the water current force component is 958 tons. You imagine what is the magnitude of force it is coming. And when you take on root 2 kV, that kV v square, and v square variation is root 2, we have to take it. So with that, the value of the water current force is very, very predominant. Yeah, these are all the calculations for how we have arrived at the water current force and everything. And each calculation has been checked manually as well as the Excel sheet manually and everything. And you can do the same foundation manually also. You can do with the STAD also. You can use some software also. Yeah. So now coming to this lateral load carrying capacity. See, the lateral load carrying capacity will be done using the some softwares. There are so many softwares are available in the market. So actually, I use L pile as well as the all pile also. All pile for the spun piles we have used it. L pile we extend we have used here. And moreover, when you do with manually, whatever the computer says, we are doing. So rooms to the Rankin's theory and thing. So he has given different charts for the non-cohesive soils and cohesive soils. Even in the same chart, he has given for fixed pile and a free head pile. So present case is a fixed head pile, but we have checked the design of lateral load pile. Considering the free head pile, we don't want it to fail this foundation. We wanted to be a little conservative. That is why we have did it. And so we calculated everything. I can show you the factor of safety. See, all whatever the water current force, whatever the except dead load, everything is a factored loads only. Whatever the tower loads these are all the factored loads, and water current force we have adapted a 1.2 factor for the flood condition, extreme flood condition. So with that, my lateral load carrying capacity of single pile, the factor of safety I got is 1.09. It attracts a single pile of 1200 dia. It attracts, as per the stat, it is coming around 38.8 tons. As per manual design, it is coming around 37 tons. So we have taken a manual design for comparison because we are doing the manual calculation here. So that is the reason why we are done. And the minimum embedment length beyond cover depth should be 1/3 of the cover depth should be there. Here it is a huge values are there, but in other things, at least the embedment length should be 1/3 be there. Yeah, this is the complete template how to design and correlate and other things, and these are all the reinforcement details also. If you see here, a lot of curtailments are there. So this entire pile, few people are providing the same reinforcement, whatever the maximum is coming. See, if you see this pile reinforcement distribution also, it varies from around 3.8 or 4% maximum you will get it, from up to 0.8% or 1%. Generally, we keep 1% is the minimum. So even the pile curtailment also, it takes a lot of time and you have to do very carefully. And whatever the arrangement we are taking, it should be symmetrical with reference to the same sections. So you can see the file reinforcement. See the head 2632 plus 2632. That means we have taken a 26 is the one of the base configuration. With that, we are playing with a 2 into 26, 1.5 into 26, 2.5 into 26. Like that, everything will playing with that. And we are also using the, depending upon the percentage of steels and everything, either it is a 32 mm rod or 25 mm rod, like that we are playing and doing this one. So all these things, see, you can optimize a considerable amount of steel. See, if you don't do, and if you put the uniform steel for 32 bars, you will use a considerable amount on the reinforcement. So because wherever I did it, I did the curtailment and everything is doing well. And especially southern region rivers are, their flow is very systematic and streamlined flow. And if you take the northern rivers, especially Bihar region and all, the river, it course changes, regression of the river or the diversion of the river flow is very huge, especially Ganges, Koshli and Gandak. There few places it runs for 5-6 kilometers, the bed of the river. So 1 year it will be at the center, 1 year will be at the corner, one corner, and other year will be other corner, and a large part of that surrounding districts will be inundated with at least 10 feet water, 5 feet water, and people also migrate that 4 months or 5 months from one place to one village to another villages. Yeah, actually, I did one spun piles for one 4-storied building in Indonesia. This is one project. Actually, this is the shoreline. Uh, this is the shoreline. This is the oil terminal. One gas terminal is there, and besides one big multi-stored complex and very big mall is there. So in this side, and if you come right side after 200 meters, there is a perennial river. That side adjacent to the river, there are two houses, there are two powerhouses, and other things are there. So if you see this soil, and Indonesia is a very critical for it comes under a seismic zone of 4. Actually, when I entered into this project, it is an international project. I have entered on behalf of the lender side to control the design and see the safety of the structure is ensured or not. So when I entered, half of the design is over and everything is there. Then I have seen the complete data and I have revised the seismic grade to next level and even the seismic load calculation that soil factors and other things I modified. There is a considerable increase in the seismic load. So this is the thing. Below is the GS substation, and this is the GS substation cable vaults and other thing. This is the GS substation. This is the 4-storied annexe accommodating the control rooms and some offices and other things. So this is the cross section of this one with the crane and other things. So this building was executed by the GE. And if you see the Borlab, see these are all hardly 2, 3, and at around 26 meters we got SPT value of around 22 or 23, and after that once again it is going back. So what we did is we terminated the spun piles, because the selection of the spun piles is we want to reduce the dead weight of the pile also. And here we have fixed something around 24 meters and we have kept around 6 meters cushion so that the load dissipation and everything will be there, and accordingly it will dissipate. So based on that we have developed the design, and we have used the spun piles, locally available spun piles. So we have used 400 dia piles. Actually, I wanted to use the 400 diameter, still stronger pile with a better rupture of modulus. But because of the government complications and some agreement issues, we have taken a moderate value of thing. Moderate thickness and moderate value, and so we have done everything, analysis and everything, and accordingly we have planned this type of this one 6 piles and some different combinations for the pile groups and everything. Accordingly we have done this is the pile groups, different piles, and these are all the loadings and other things, and these are all the deflection checks. So individual pile, this is the vertical load deflection, this is the lateral load deflection, this is for the single pile, this is for the group action. We have done everything with the all pile software for this project. And believe me, this piling cost escalation is around 2 to 3 times. They were because after seeing our because we are from the lender side, and lender is very particular about it. It's an international aid project for the Indonesia. So one European government is giving the complete aid with a very nominal payment terms and everything. That is why they accepted this one and they constructed everything. And for this one, they have gone for the hydraulic piling, and the hydraulic piling is very costly affair. So in a hydraulic piling, I didn't have photographs because after design finalization, I came out from this project, and my colleague had been there for the execution and everything. So there you will find what is the frictional resistance of the pile, what is the bearing resistance of the pile, everything, each pile you will have a record on that. And see, my estimation of this lateral load is very close to the actual testing figures. Up lateral load and uplift, whatever I estimated, we got very close results. And my colleagues from Germany and UK, they were really appreciated our efforts and everything. Because on behalf of Brussels, I worked for this project, so they appreciated like anything. Yeah, this is the spun pile, one piece to one piece welding and other things, and this is the pile cap connection for the spun piles. So between that only the whatever the soil strata is, subsoil strata will be there. The last 2.5 3.5 meter we will keep some concrete and reinforcement to connect with the piles and other things. Yeah, now I will show some pics. If you don't provide, if you don't adopt appropriate value of cover depths and improper embedment length, what will be the state of the foundations? This is the one foundation. I don't want to name it. It is very close to go. It is in Bihar, northern Bihar. It's very close to the Nepal. So you can see this stretch is around 4 to 4.5 kilometers, and already failed, and it is on ERS, emergency restoration system. The line is in emergency restoration system. See the level of covering. This is the pile foundation they put it, and one of the two pile foundations are washed away. And this pile foundation, we have suggested some kind of retrofitting of adding additional piles with modified cover depth and everything. So you can imagine, see, in a few hours it will be eroded, because I seen the live video of the one tower failure. The tower is located on the bank approximately 85 meters away from the bank, and that tower was intact. It was doing very well. And after we left, after few months, flood came, and that tower was failed within 4 to 5 hours. That side, the entire flow is concentrated, and the entire bank was eroded. Yeah, you can see the tilting of the pile foundations because of the inadequacy of the cover depth and the embedment length. These are all the fails. I don't want to name the project names and also, because these are all very confidential, because I was a technical due diligence party for this. That's why I got these photographs. Okay. Yeah, the same thing we have done with something like that, and we have analyzed with L-pile the same foundation for all the things, and these are all the settlement because the one party wanted to purchase this line, other party is selling this line. So the purchasers party is having a foreign aid and other things. So their foreign consultant asked me to show the what is the actual deflection of the pile cap. So when we taken the without liners effect, the deflection is something around 350 mm or so. If you take the liner effect at the pile cap level, it is around 150 mm. So these are all the things we have done and we showed it. But he wanted, see, the river crossing towers are very flexible structures. They can take flexible means the rigidity of structure is not there, and they can take certain deflections. Whereas in bridges and all, they are the rigid structures. Any excessive deflection will create additional movements. Because see, in none of the earlier old designs of the river crossing pile foundation, they never checked any deflection. This time only we have checked the lateral loads and everything. And earlier it was the mainly thing is the lateral load is the governing thing, and they are doing extremely well in other parts of the things also, other parts of the country also. So they are doing extremely well. Only thing is one has to be very careful about this cover depth. Yeah. This is one, see, in Egypt, we have done one big park is there, Aswan, this bay in solar park. There we have done 6 plots of 50 megawatt with trackers. So for these trackers, we have used the steel piles as rammed piles, and so for this one also we have used the steel sections. So this is the central pole is the IPE, and other things are the some are the C channels, and some are the light light sections also, light I sections also. So central post where the mechanism and the drive mechanism, everything is there. This is IP 140. So these piles we have designed in. This is the kind of tracker, and the central post will have experienced the complete control mechanism, and it has subjected to higher magnitude of torque and other forces because of the uh, controlling mechanism. It is attached with some kind of motor. It is self-driven, self-charged with PV panel and other things. So these things, all these coordinates have been prepared with. We have used the civil 3D, and we have raised the this height of post. We have not did any grading or anything, and accordingly we have developed the coordinates for the what will be the height to tracker height, everything with GPS coordinates and everything, and height of individual posts also we worked out with an Excel. Macro we have developed it, and with that we have done it this project. So there also we have used the LPIL, and we have given the design. It was validated by the Cairo University, technical university, and they tested, and all the results are satisfactory. The project went very smoothly, and here I wanted to show some figures. Yeah, these are all the things. Okay, these are the part of the desert, and the top 600 is some desert, and look like that, and after that it's a very strong soil. You can see this is the rammer. So it will simply drive the post into the thing. I will show you the one video also afterwards. So there they are using even this one this periphery boundary one also. These are all precast pile foundations with post, everything, and everything will be brought with hydro, and they will fix the thing. Yeah, this is the finished one. This is the things. So I think this kind of things we have not done. Only we are doing the precast RCC, but this foundation is a precast one. Yeah. So this is the one of the renewable energy project. So it's around 400 megawatt, and it is spreads for more than around 1,000 acres or so. So these are all the micropiles, concrete micropiles without any reinforcement. It is varying from 1 meter to 2 meter, and 250 to 300 piles are being used. So I could say that this project for 400 megawatt they completed in 4 months. They worked around the work from green area to the plant commissioning. They took 4 months. Of course, they completed more than 2.2 lakh micropiles in this process. So there were some issues about the micropiles, and the quality analysis and review was done by me on behalf of my company. So yeah, these are all the things. As you said, the CFA values, the design parameters, this matters a lot, and everything. A lot of quality checks. You can see the quality of the concrete. It is M25 concrete. You see the micropile surface. When we tested this pile, this course and all, it is not even given the M5 grade concrete. So you can see the irregularities and other things, and honeycombness, level of honeycombness and other. Yeah, these are all the some of the things in different projects. So see the eccentricity of the pile foundations and honeycombness of this foundation. This analysis and all we have done with this one. Okay. Now I will show you some of the things. Actually, when I was a superintendent engineer, the in charge for the design wing and as well as the execution also, this building was executed by me at the while I was just about to leave the government service. So this is a control room. It is constructed on 14 meter earthen bund. It is a pure black cotton soil. whatever the block cotton soil, they got it for the pump house. It is the Devadula lift irrigation project near Tupakul Gudam. That's the first intake of Devadula lift irrigation project in in combined Andhra Pradesh. So we have provided these openings and 600 thick raft with small pedestals and a single control room. And there were a lot of challenges whether this structure will stand or perform well or anything. And when I was doing this PCC, that time the ENC of irrigation and CAT department and my top officials, directors came to the site, and they put lot of questions about me, how it will be doing another thing. Then at the same time, the irrigation contractor is having the vibro roller. We have shown the trial run of the vibro roller, and there are no appreciable settlements and other things. We have taken 5 tons capacity, and we did lot of compaction. After we got this embankment, and we started construction after, I think, 2 weeks or so. After that, we did lot of compaction and other things, and we have designed the complete raft foundation with 5 tons bearing capacity and other thing. This design and everything was taken by the irrigation department, because they are the final author of that, and the entire substation is built on the complete embankment. You can see the failure of these photographs. I got it recently. See, you can see the failure of road and cracks, other entities also. Okay, this is the one of the thing we did it. And similar way, we did one more project at Basara. Near Basara also, one more project is there, Ali Sagar. There also the same way we have done same thing. Yeah, this is the one subload load dispatch center for the electrical load dispatching system and the grid stability system. It is a Government of India aided project. We have done it. This was constructed in Vijayawada. I think people know that Nunna area, where especially that power grid substation is there. In that power grid substation, we have constructed this one. Besides that, there was a power grid quarters, and there is a commercial, there is a market colony was there. Also they developed it. The entire market colony was constructed with a CNS layer. It is a typical block cotton soil. The width of the crack is more than 2 inches, and the depth of the crack, nobody knows what depth it goes. So at that situation, my chief engineer asked me, can you able to design here or anything, or what you will do? Then we went and we have designed under limit piles, and we have applied all the 10 clauses, all the things we have claused it. And this figure, I think after 20-25 years, so the roof recently, it seems that is having some problem. They removed some leakage is there. That's why they removed the roof and they put the sheets. But the entire thing, you can show that different views of the photograph. You will never see a crack.
Sir, sorry to disturb you.
Yeah.
Sir, could you complete in 10-15 minutes, sir, maximum? After that,
Yeah, actually, it will
take
go
some
over
questions.
another one more slide only. That's all. One more slide.
Okay, sir. Okay, sir. No problem.
Yeah, this is also one journal office building for the central office at Kadapa. Actually, initially we have designed the individual foundations for the G+2 structures. It was considered G+1. So accidentally, I had been to there some other issue, and then I wanted to see the site. Then we went there. That was a heavy rain is there. Then I asked somebody to bring the cow bar. When I put a cow bar, it is going like a very soft. It is going. Then I discussed with my chief engineer. Then he laughed at me. Are Kadapa zone mein, why you are thinking like that? It's Kadapa. It's everything is rock. You are telling. Then I convinced him. I told him this is the issue, and then next day I have taken some photographs with my people, and I showed it the existing buildings, nearby cracks and other thing. Then here also we did the underrimmed piles. Yeah, you can see some of the pics. Some leakages are there. I'm not saying that. So all these things. It was with my association. With I was involved, associated with all these things. So this completes my the presentation. Yeah, one more thing I wanted to say. Recently, if you say this one first toll gate near towards Vijayawada side, that is what is that Chautopal. So there is a 1 kV substation is coming there. In 2020, I landed here, and one of my colleagues want me to relook about. Actually, somebody has advised, one national institute has advised to go for the pile foundation for this building. So these are all the piles they have designed it, and they are facing problem. They laid the 2 piles, and they called me to have an opinion about. Actually, he is the chief engineer, and he has worked with me. That whatever that embankment work was, he was completed as executive engineer. He called me, and I went there. Then I saw the profile, and I also took some trial pits, 4 5 locations. I said nothing is required. You just go for the ordinary raft as a precautionary measure, and they completed the ordinary raft, and this substation also charged, and everything is like this. So that's what I'm telling, that see, we should be very careful about the public resource and whatever public or private resource, but your judgment should be uh, very judicious. Actually, if this building goes for a pile foundation, many of the buildings are not at all fit for ordinary foundations. So I don't want to name it, but they have given a big report, and they recommended piles for this control. So this is my last slide. So I'm not saying that I am shared my personal experiences. Probably I may be wrong in few of the things. I'm not saying that. So whatever we have to do it, we have to do diligently. So any questions or anything there? If I talk anything wrong, please excuse me.
Dear participants, please unmute yourself and ask the questions.
Good afternoon, sir.
Sir, good afternoon.
I'm Hussein.
Yeah. Hussain sir, please.
Yes, sir. How are you, sir?
I am fine, sir.
So your presentation is very nice, sir, and actually it's very valuable. Huh? So experience on the field is very valuable. So I have only one doubt, sir. You are
Sir.
telling about scouring. Okay.
Yes.
Scouring will happen at any depth of the
Sir,
pile.
covering with the normal flow conditions is very, very small magnitude. Covering with flood associated with high velocity is huge. So all the cover failures are when the river is in speed.
Yes, yes. So even Bihar also recently.
Yeah, same thing. See
collapsed.
that 17 slides you please see, because I had been to their rivers, because I do technical due diligence for the transmission lines. One party sells, one party purchases. Like that I go. That time I saw so many things, and the locations they have laid very poor quality, poor classification foundations and other things. That is the reason, sir. See, the cover depth calculations in Kosil's time and now present time is different.
Sir, I have another question.
Please.
Recently, they constructed one bridge on sea near Bombay.
Sir, in sea, the current is there, but the flow is less.
Yes, correct. But the depths will be very large, no? So will they go to the bottom of the sea?
No, sir. Sir, nobody will
The
go.
pile depth.
See, No. So, sir, generally, there also they will calculate this cover depth and they go up to SPT values something around 60, 50. That is more than enough. Actually, that Narmada River crossing, we have kept it around 22, 25.
No. What would be the normal maximum depth, sir? Pile depth.
No, so it is not, sir. It has to satisfy the geotechnical design first. The
So
load carrying, whatever the load coming.
will it be in kilometers?
No, it will not be in kilometers. How it will be in kilometers?
That's
So,
what I'm telling.
no,
Because in
no, sir, it will not be
sea,
in sir, kilometers. Is execution is the see nowadays many offshore wind turbine foundations are coming in deep seas. They are some are floating, some are anchored to the bed, some are in
floating. Yes. Yeah, yes.
floating with anchors and other things.
Yes. Okay, sir. Thank you.
Thank you, sir. So,
Sir, this is Satyanarayana, HOD of Civil Engineering, sir.
sir,
I have one doubt, sir. Your presentation is very excellent and so the slides are very nice to understand the ND1. Sir, can you test all piles in a group piles or any one pile is in group of testing is
sir,
sufficient, sir?
testing will be random. You see, I can test all piles, but what will be the cost of my project? If I employ a hydraulic rig or a sophisticated rig, I can have the load-bearing capacity of each pile. So generally, 1 in 100 or renewable energy, even 0.1% of the piles are not being tested.
Okay, sir. Thank you.
Sir, one question is there in chat box.
Uh,
So how to monitor the performance of pile foundations? So this is a question from Hemalata madam.
Ma'am, actually what we will do, see, before laying the caps itself, we should ensure the soundness of the pile. For that, we will conduct the PITs. PIT will give the picture, any combination or any neck formation or anything. Then that should be addressed first. Then only the pile cap has to be laid. So after that, regular O&M and sometimes every 10 years or 15 years also you can do PIT. PIT can be done at any time. Because the projects I shown, I conducted PITs. There is a one more slide because I didn't have time. Otherwise, I would have showed even the testing of piles and the testing of non-destructive testing of the conventional foundations also. Only thing is the surface should be dry, but PIT you don't require anything.
Any other questions, please?
Sir, it is very important to use good quality concrete. That is most important, sir. Many of the failures are attributed due to poor quality of the concrete. See, none of the renewable projects, we are not using a single rod as a reinforcement. It is just micropile. It experiences 1.5 tons compression or 1.4 or 1 ton uplift and approximately 400 to 600 kgs lateral load.
Spacing between two piles, how much, sir? It should be?
It should be generally 3, sir. You can go up to 2.5 in stiff layers.
Oh.
That's overlapping. See, that overlapping of pressure bulb and all, these are all most important, sir.
Sir, one more question is there from Dr. C. Lavanya madam. How many pile load tests will be conducted on the working piles?
That depends upon your specification, madam. Generally, 1 in 100 or so we will suggest. Ma'am, piles, if it is failing means the interpretation of the geotechnical report or the execution is not good. Because I have seen Godavari river crossing piles, it was done in 80s. There are so many problems are there in the design because whatever design I did it, many times it was validated by 4 times it was validated by IIT. Then afterwards Daratna sir, and even JNTU, and some people, sometimes we have only did everything. So the mainly the quality and the geotechnical parameter, uh, appropriate choosing of C5 values. This concentration of flow, I had a big fight with Professor VVSN Razu and team. And Professor Elango from IIT Chennai in 1990, he only supported me, and all the IITs on behalf of contractors, EPC contractors.
Any more questions, please?
Sir, incidentally, hello, sir. I'm Hussein.
Sir,
So
Hussein.
you were referring to Professor Elango.
Yes.
So he was my external examiner, sir, for my PhD, Viva.
He's an excellent gentleman, sir.
So
So
really, he
it's
has.
a very big EPC, very big EPC. So everybody is on their favor. The only gentleman I have showed the IRC cause and the concentration of flow. He has the single person supported me in the 90s.
He was so, empathized with others.
Yes,
He has
that is the
consideration for
see.
others.
That is
He's
why
a great gentleman.
this country is going like this. So like very few people like him.
Independent thinking. Thank you, sir.
Thank you, one and all.
Yeah,
Thank you
sir.
very much for your patient hearing. So if
So,
any mistakes are there, please bear with me and excuse me.
sir, you explained very well about the types of pile foundations. Those are based on materials and methods. Then how to calculate the load on the piles and how to design the piles, design process. You explained very well, and you have shown some pictures which were laid across the different rivers, and you explained very well about the micro piles. Sir, thank you very much. In spite of your busy schedule, you spent your valuable time. Thank you very much, sir.
Most welcome, sir. Most welcome. And the credit goes to my team members who has supported me with all photographs and everything, sir.
Okay, okay. Thank you, sir. Thank you. Uh, Dear participants, tomorrow we have session at 2:15 p.m. That will be on IoT enabled system for water purification and generation by G. Naga Srinivas Garu. He is principal scientist, IICT Hyderabad. Kindly join by 2:15 tomorrow. Thank you, one and all. So thank you very much, sir. I will end the meeting now.
Okay.
Thank you,
I'm
sir.
leaving,
Thank
sir.
you very much.